about it either.
All right, everybody say hi, Taylor. This video is for Taylor.
Hi.
No, they don't care about you. Sorry.
Hi,
Okay.
Taylor.
There's Claire.
I like your sister.
All right. That was not very nice. Okay.
Work on Saturday, so I have to live.
So we are at the bottom of the front side of your review sheet. You should have all this stuff filled out. We have to do those 3 rows and then on the back side. And then I'm going to add a few things down below here. Just a couple more extra examples. And then we'll be done. We'll do some whiteboards. So we discussed on whatever day it was, like Tuesday of last week, the and or the multiplication, independent, dependent. Then we have ors, which are mutually exclusive or inclusive events. Okay, so in this case, you are adding. So let's get our addition ready to go. Whoop. You have a fraction and you are adding a fraction. And if they are exclusive, all you have to do is add them together. But if they are inclusive, then you have 2 fractions that you're going to add together and then what? Subtract out the middle, okay? So I say like these are the outsides, outside, and then you subtract out the middle. And what I mean by that is when you have a Venn diagram, you have 2 outsides and you subtract out a middle, okay? So
do I get one of these sheets?
In both. You don't have one of these sheets?
No.
Oh, child.
I was gonna mention something, but
No, weren't you here on Monday when we started this?
I was here on Monday, but we didn't start this Monday.
No, we started this Tuesday.
What?
Okay, anyway, there you go.
Monday we did this.
Right.
I don't remember anything.
Okay. This one I'll say you can't be in both categories. Like you cannot be a freshman and a senior at the same time.
Just you watch.
Hey, that's not not freshman, senior. Whatever.
She's taking freshman class.
Okay, whatever. All right. So should we do an example from this class?
Sure.
Including Taylor, because she's here.
But she's not here.
But
Taylor's
she's here in spirit. She's here in spirit.
And
What should we do? What should we do for exclusive?
Freshman, senior.
Freshman, senior, but we don't have any freshmen and we don't have any seniors. So,
Sophomore, junior.
and then that's everybody.
Nuh-uh. Taylor's a junior.
What? I know.
Yeah,
If we did sophomore, junior, then we would have everybody, right?
5
I mean, we
foot,
can.
5'5" or taller.
Above
No.
5'5" or taller. That's everyone.
Have you seen yourself, Luke?
Yeah, except for Mrs. Comer.
Or James?
Okay,
Huh?
let's do the probability
I'm
James
5'5".
is taller than me.
of choosing
I'm
a.
also 5'5", yes.
Boy or
I am also 5'5".
We'll do football or volleyball. We always do that one. Football or. We can do football or cross
We're all
country.
basically the same.
Let's do football or cross country. We'll make it wild here.
Except like
Wow.
Claire's a redhead, so.
Yeah.
Football or cross country, and then we'll do probability of. Let's do
cross country and girls.
cross country or boy.
Ha.
Because we don't have any girl cross country runners in here. I know it'd be confusing. Cross country or boy. All right. So football or cross country. Let's go over here. This plus this. So we have our 2 outsides. Football, cross country. How many football players do we have in here? 2. How many cross country runners do we have in here? 3. Which makes a total of. Oh, wait a second. Out of how many? 8. 2 out of 8 plus 3 out of 8. Do not reduce the 2 over 8 because you're going to end up adding and you need to have a common denominator. So I have a 5 out of 8 or a 62.5% chance of coming into this room, choosing one student and them being either a football player or a cross country runner. Next, cross country or boy. We have 3 cross country runners. We have how many boys? 5 boys? 5 boys. 5 boys. Okay. And how many of those boys are also cross country runners? 3. All 3 of them. Okay. So I have to do 3 over 8 plus 5 over 8. And I subtract 3 because you are counted twice. And heaven forbid we have 2 Lukes or 2 Kyles. Or 2 Jameses, but he's pretty quiet. So we'll mainly, it is 5 over 8. Yep. Mainly, we don't want 2 Lukes and 2 Kyles. Okay? Beautiful. How's that? All right. Conditional probability. These are the given statements. Like something given, something else has happened. Okay? And your given is always your bottom number. So in a fraction, the given goes down here. Whatever your given is your new bottom number. It is no longer the total. Total is now gone. And then your top number is out of those how many you have. Okay, so you have a fraction, something given something, your given goes on the bottom. Okay? All right, let's do a little Venn diagram here. Not a Venn diagram, a two-way frequency table. Who do we have in this class? Just
Boys.
sophomores and juniors?
Yeah.
Sure, great. And boys and girls. So we'll go sophomores, we'll go juniors, we have boys, and we have girls. Okay? Is everybody a sophomore except Taylor?
Yeah.
Okay, so we've got 7 sophomores total. We've got 1
Wait.
junior.
You're our thingamacdoodad, you know what I mean?
Teacher.
No, not our teacher. Our class representative, whatever. Class
Uh-huh,
advisor.
uh-huh.
And you don't even know who's a sophomore.
You know, help me out here. I'm
What if
whatever.
you're one of the special kids who don't know what they are?
boys. How many boys do we have in here?
Kyle.
5. And girls is 3. And 5 sophomore boys. We have 3 sophomore girls.
Does everyone claim to be the junior?
We have 1 junior girl and 0 junior boys. Did I fill that out right?
Kyle.
Somebody check that table.
Yes.
Great.
No, what?
no,
5 plus 3 is
sophomore
not
girls
7.
is-
Yeah.
Sophomore girls is
2.
1.
Oh, wait a second. Sophomore girls. Yes, you're right. Ha. See, that's why I had you check.
That's because your
That's-
mom.
That's
Ha.
because
2.
you're testing.
2. Okay, there we go.
What
All
did you
right.
say?
She's testing.
I want to know the I'm testing to see if you're paying attention. I want to know the probability of having a girl given that we have a sophomore. Okay, and then I'm going to do one more. We're going to do probability of sophomore given girl. Okay. Let's see what we get. Girl given sophomore, sophomore given girl. Do you want to try this on your own? Just try it.
We're reviewing the stuff that I already know.
Great.
It's all the stuff above here that I needed.
Great. I'll give you the paper.
Oh, I thought you were like dying. I thought you were having a heart attack.
Okay, did you get it figured out?
No, just.
Girl given sophomore, sophomore given girl. You will sometimes see this notation instead. You might want to write this down. Sophomore given girl. Have you seen me use that notation before where I use a straight up and down line? That means given.
Yeah.
Sophomore given girl. Okay.
Sure.
So if you see that notation, that's what that looks like. Okay. All right. Girl given sophomore. Let's do that one first. We start with the
7.
sophomores. We only care about sophomores right now, and that is my bottom number. And of those, how many are girls?
2.
2 out of 7. Okay. Sophomore given girl this time. Now we are only looking at the girls, and there are 3 of them. And how many of those are sophomores? 2. Okay. It is worth mentioning that girl given sophomore, sophomore given girl, we have just flipped those 2 around, but the fraction is not just flipped, right?
Yeah.
Okay. It really is altogether very different. All right. So don't just rely on that. Okay. Good? All right. Moving on to the back side. Geometric probability. Circle, square, triangle, rhombus. We have let's do equation.
This isn't geometry. Oh, wait.
Yeah, it really is geometry. Equation. We have variables. We have an example. And we have a solution. Okay. So, in each one of these, we're talking about area. So, area of a circle, area of a square or rectangle, area of a triangle, and area of a rhombus, which we haven't gone over the formula for, but I'll show you what it is.
One time I was in a store. Okay.
Uh-huh.
You'll see my point.
Hey.
You like are in a store like every single day. Jason.
No, not that store. It was
A store.
It was like a home decor store because my mom dragged me in.
And she did need to know the area of a
Okay.
circle.
Okay.
No, it was a random lady who
You
did.
said-
And guess what I said? I don't know.
Oh my gosh,
And
girl.
walked away.
You said your mom drug you into the store. Okay. Never once have I seen a girl not want to
Quit.
barge into a home decor store. It's ridiculous.
Okay,
Every
anyway.
time we
Circle,
honey
She's
bun.
like, we need to stop, guys.
Well, we can stop now. I mean, we don't have to
I
fill this
just
sheet
wanted
out.
to-
Hey, we all need to shut.
All right,
We don't
area of a
care.
circle. I mean, this is for you for your test,
Just
so
stop.
We can
It's
just
like-
leave the rest of it blank.
Radius times pi squared or whatever.
Pi r
That's
squared.
what I told her, I don't know.
Pi r squared is the area of a circle. Pi r squared. What does r stand for?
Radius?
Radius.
I think I actually like told her the complete.
Okay, I'm gonna write down one other thing.
Teachers, please dismiss the juniors and seniors for the college fair.
I'm gonna write down one other thing, which is D for
Diameter.
diameter. Don't get these two confused, because the diameter is not the same thing as the radius. Diameter goes all the way through. The radius is only half of it. That's what we want. Okay, so my example is going to be this. Let's say this is 8.
Guys, do you guys know where your radius is? It's in your arms.
Wow.
All right.
That's how
So
much-
example: circle 8. What is the radius?
4.
4. So we need to do for area
16
pi times 4 squared, or 16 pi, which is something like, I don't know. I was
You
gonna say
don't- you
48, but
don't
it's bigger than 48.
803.
What?
803.
No.
Yes.
16 pi? No.
16 times 3.14.
No. Don't use your pi button, child.
I don't have a pi button, child.
You need a new calculator. Did you? Yes, that's the one that you want. Yes, sir.
Your calculator's so
Oh,
old it
here,
doesn't have
Put that
pi.
away. Put that away. 16.
It doesn't have
Is,
pi. It was
right.
invented before pi.
16 pi. Look how easy that is. Read me that number. 50.27.
265.
Wait, who invented pi?
50.27.
Got
And we'll
it.
say each one of these
My
is
mom
in
invented
inches.
pi.
Inches squared. There you go.
No.
Good? Happy with that?
Do we have to write that?
Hey, do you guys want free ginger snaps?
You have to put the units on the end of it.
Or whatever.
All right, next. Shh.
Whoa, Jay.
Square rectangle.
What?
Here's your
They're
example.
like shape addictive, man.
You guys, come on.
Talking about language.
Wait.
Luke
Okay.
is distracting.
Area, formula. What do you got?
Length times width.
Length times what? I'm going to go base times height. B equals base. H equals height. You can go length and width. I don't care. Okay, base times height. What's the area?
15.
15. 3 times 5 is 15 inches square. We're going to say all of these are in inches, just for the purpose of the thing here. Okay, triangle. How is that different?
It's half the base times the height.
It's half the base times the height. Or you can say base times height divided by 2. However you want to write it out there, you can write it both of them out there, I don't care. Base and height is the same variable. Base times height divided by 2. So let's do, I'm going to give you a kind of a tricky one maybe. Let's say we've got 7 and we've got 5 and we've got 4. No, the other way around. We'll go 5 and 6. How about that? Okay. Oh man, there's my triangle. Area equals. Okay. What's the base?
7.
7. What's the height?
5.
Are you sure?
No.
Yep, it is. It is the perpendicular height. Never, never, never the slanted height. So you always want to go with the 5 and not the 6. That's why I put that in there, just to confuse you.
Half 35.
So what's half of 35?
17 and a half.
17 and a half inches squared. You betcha. Okay? Happy with that?
Yeah.
Not too bad? All right, rhombus. I'm not giving you the area of a rhombus or the formula for area of a rhombus. You will have to memorize it at the end of this chapter, or at the end of this year, like chapter 8, I think, maybe is when we do it. Okay? It is 1/2 the height times base 1 plus base 2. Okay? H is height. Base 1, base 2. These are the lengths of the two different bases. Okay? Doesn't matter which one you designate as base 1, base 2.
Nope.
Nope. Nope. Okay, here is my trapezoid. No. Rhombus. Rhombus? Rhombus. That should not be a rhombus. That should be a trapezoid. Blah, 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 blah.
What the heck?
Trapezoid.
A rhombus
Woo!
is really easy to do, and then you were confusing
That's
me
not a
about
rhombus.
what's
That's a trapezoid. We're switching to a rhombus is a diamond. We'll talk about rhombus later, but trapezoid. We're doing trapezoid now.
Be simple than that.
Okay.
I was like, I never don't remember doing this.
All right, so let's say this is 10, and this is 6, and this is 8.
What?
Okay? All right, let me just break down for you. How the formula is brought about, because this can maybe help you remember it for when we see it later. Ready? When you're finding the area of a rectangle, it is base times height. Base times height, right? Okay, here, this is the base, and then we have a height in there, right? We have two bases going on. They are 6 and 10, and it's like, oh, which one do I use? I'm going to use the average of the two. How do you find average?
Add up.
You add them up and divide by 2, right? Or take half of them added together. That's exactly how this thing is put together, this formula. So it is literally base times height, except we can't decide which base we're going to use, so we take the average of them, right? That's how this formula works. That's how this formula operates. It is literally base times height. Okay?
You get 60,
So area equals 1/2 the height times base 1 plus base 2. Not multiply.
So half of 8 plus
Times 6 plus 10, right? Or 10 plus 6.
Okay.
Okay, now, the biggest mistake, don't multiply the half by the 8 and the half by the 16. No. Do only one or the other. So
Okay,
half of
anyway,
8,
So then that simplifies down to 4 and 16.
what is 4 times 16?
64.
64 inches squared. You betcha. 64 squared inches. Okay? Good? Beautiful.
You hyped that up to be way harder.
Yeah. But I'm just showing you. So when you have to memorize the formula, though, that's a way of remembering it. It's just the average of the bases. Okay, go down to the very bottom. You will see examples for geometric probability that looks something like this. I'm going to go off the same problem that was on the quiz. And
What quiz?
the quiz that we took, the mid-chapter quiz.
Oh.
And it was I think it was a square inside of a circle.
Oh, yeah, I guessed.
Okay?
Square inside of a circle.
I think it was a square. Oop.
Square.
Square.
Oh, yeah, I guessed and I got it right somehow.
I don't remember if I got
I
it
basically
right.
found the area of the circle and then I subtracted the area of the square. And I don't know if I did that right, but like, I got it right. So.
Okay.
I don't remember.
All
if I
right.
got that right.
And here we go. We have units here, and this is 2, and this is 3. Okay? And the shaded region, the region that we're shading is this guy. So we want it, whatever dart that I'm throwing, to land inside of the square. Okay? So this is a geometric probability question, okay?
Okay,
So we have, this is how this works. We have total area, and we want the shaded area, right? So it's shaded area over total area, right? Okay. Well, what shape just so happens to be the shaded area?
A square.
It's the area of the square,
So it's 4.
So it's
okay?
16.
Versus, it's not, yep, yeah, just wait. Ooh. Over where the total area is the area of the circle, area of circle, okay? So that's what we're doing here. We have area of a square over area of a circle. Now, Chase said that this area of the square is 2, or is 4, excuse me.
Yeah, I forgot.
But Luke says 16, because what is the length of the base?
4.
4. The length of the height here is also 4, because it's a square, right? But do you see where they get 4 from? 4 by 4? Because 2 is only half of it right here. Okay, so it's a 4 by 4, so the area of the square is 16, okay? And then we have to do the area of the circle, which is pi r squared. What's the radius of the circle?
7. Wait, no.
5.
Sorry, I'm
It is 5. It is not 3, because going from center to the outside, that is 5 units. So 5 squared times pi. We do 16 divided by 25 pi. And if you enter that into your calculator, you may
78.5.
need to put the 25 pi in parentheses, or do it before you divide it by 16. What is that? That is a decimal.
78.5.
It's like 20%.
Is the bottom line.
It is
78 point whatever.
20.4%.
20.4%. Yes. I will buy that. That shaded region is 20.4% of the entire region. Makes sense?
Then we
Okay?
have, like, a
But break it down. Do baby steps. The shaded area over the total area. Okay? The shaded area is the square. The total area is the circle. Yeah? Happy with that? Okay, one more example. Do you have room at the very bottom? Let me make sure that's my last example. Yep. Okay, here we go. Example, and this you might not even need to write down. Bus comes every 37 minutes. What is the probability of wait longer than 5 minutes? What is the probability that I'm going to wait longer than 5 minutes? How in the heck do you do this?
The time thing we do that.
The time thing, like what?
The timeline thing we do that.
What?
Draw a line.
Draw a line. And best case scenario. I show up as the bus is coming and I have to wait 0 minutes. And worst case scenario, I show up as the bus is leaving and I have to wait another 37 minutes before a no bus comes. 5 minutes is going to be all the way over here in the very beginning. And I want to know waiting longer than 5 minutes. So that's basically like how long is this in comparison to the total?
5 subtracted by 37 is 32 out of 35, or 37.
32 out of 37. That's my chances, which as a decimal. Somebody want to calculate that for me? 32 divided by 37?
That's a number right there.
It is.
It for sure has a decimal in it. 0.864. So like 86.4% chance that I'm gonna have to wait longer than 5 minutes. That's pretty good. Pretty good chance I'm gonna have to wait quite some time.
Well, it's
Okay.
a better chance than waiting 37 minutes.
Right. Anyway, okay. Happy with that? That's all I have for you to put on your sheet. Okay, everybody say bye, Taylor.
Are we
Bye,
done?
kids. Have fun.